Yes, indeed, steel is durable, but also one of the main benefits of steel for a circular economy is that it can be constructed with reversible connections. So we know assemblies that are made of bolts, for instance. Those bolts can be removed, can be taken away, and that means that the parts of a steel structure, for instance, could be reused in new loops without destroying the pieces of steel, and that's a unique feature of steel compared to other materials. Today, whenever a steel structure or steel components reach their end of life, the best thing we could do is to recycle the steel. So that means that we would melt the parts and we would remanufacture new components. And that's nice. It allows the savings of greenhouse gas emissions. It allows the saving of waste. It's efficient. We can now commonly buy steel with recycled content in it. But the reuse approach potentially could reduce further the greenhouse gas emissions or related to the reprocessing and to extending the service life of the steel components. And so that would be one major argument in favor of reusing steel rather than recycling steel, for instance. So in the reuse approach, we want to keep the component with its given geometries, with its given mechanical properties. And so that means that we don't need to reprocess the steel. We should ask the question, why aren't we reusing steel today in large extents? In my opinion, the main reason is that we don't know, we are not used to do it. We don't know how to do it. We don't have precedents. So people or practices before us who have reused steel over and over, and so we cannot base preliminary judgments based on that. We don't know how much it will cost. We don't know if the steel will be in good quality or not. We don't know if the dismantling process or the transport will deteriorate the quality of the components. So it's hard to guess because we don't have precedents, but it doesn't mean that the answers to those questions are negative. So it's not because we don't know what would be the associated cost that it will be more expensive. It's not because we don't know how the dismantling of the building will happen that the parts will be destroyed after dismantling. So we need to gain confidence, and I mean it's an argument that goes against. All the arguments that goes against the reuse of steels are based on this lack of information that we have about the reuse practice, the practice of reusing steel. And so what we need today to address this issue is really examples, case studies, and so on. It depends a lot on whether the steel components still belong to the same firm or people or not. So if the owners is the same, it depends a lot if the steel components are reused on the same locations or not. And the short answer is that some aspects need to change in the current regulations. More specifically in the way the tenders are attributed. So in the tendering process should change the chronology, so the sequence of let's say responsibilities and expectations for all stakeholders in the design and build process. All that sequence needs to be updated actually to allow the reuse. Because I mean the main difference, to give a precise example, is that if we want to reuse steel components in a new building, in a new structure, we need to know about the availability of those components during the design process itself. There's been some examples, recent examples, where that could work. So steel could be reused because the client was okay to advance the money and to pay for the components, although no permit was given already to the building. And that's a huge risk that they took. It was worth it, but the current way of attributing markets and so on doesn't allow this type of risks. And we should find ways to make that process risk-free. It's very hard to get data about the reuse of steel when the structures are moved from one place to another, but still belong to the same owner. I mean, if the army is dismantling a hall and rebuilding it somewhere else, this is a data that we cannot collect. If any firm is dismantling and rebuilding a hall or storage facility, whatever, then we don't know that data. In terms of architecture, so projects that were designed by architects, there is a famous, now famous example designed by Boubureau in situ in Winterthur. And this is the first recent example of reuse in an architectural project. So where the designers claim and present that they are reusing parts because it makes sense for the design of the building. And maybe the practice was a bit more common during the very first days of steel, and maybe also during the days of iron, so after right in the industrial era. So end of 19th century, early 20th century, probably that reusing steel parts was just common practice. But again, it's very hard to get data about that practice because it was so common, so banal that it wasn't documented or published at all. But if we look at the way old buildings were constructed, it's very easy to notice that they were constructed with the disassembly in mind. So the connections are are usually reversible, and of course the designers had in mind that at some point the steel parts of the building would be dismantled and potentially reused somewhere else. We lost that practice, and now it's coming back, but the examples are very, very rare. In Switzerland and elsewhere in Europe, it's the same issue. First, we must remove all the fears that surround the practice, and that goes by developing and promoting more and more examples and applications of steel reuse. So that's the first thing, because yes, there are fears, and as there are fears with, every time we don't know something, we fear the unknown, but we must go beyond that, and examples and experience can help that. That's the first thing, and then the second thing is to also allow the looping of the materials, and maybe there are new market opportunities for steel manufacturers, for steel distributors, for steel refurbishers. So maybe also new types of jobs for what we would call material hunters. So people who are aware that certain buildings are about to be dismantled, and that there will be available parts for new projects. And I mean, in order to allow the flow of materials, first we need to secure and to make sure that there is a flow of information in between projects, demolition projects and construction projects. And so this is probably a second big strategy, is to allow these flows by creating new dynamics in between stakeholders and by sharing the information. There is a need for precedence in the practice on steel reuse, but there is also a need for research on steel reuse. On one side, the technology could be improved. So what new connections between steel parts would be appropriate, or how could they be improved in order to ease the dismantling, in order to ease the reassembly, not in the short term, but also in the very long term. So after maybe deformations of parts of the components, how can we make sure that those parts could still be reused, although they're a bit deformed? And this is just an example, but there are a few directions for new research topics. In the lab at the DSXL, we've been also working on the design process itself. So if we start designing with a stock of reused components, the design process for the engineers, for the architects, is completely different, because usually we would have an idea of so the big picture of the project, of the shape of the structure, for instance, and then we will start analyzing and detailing the project up to a point where we know what to manufacture, and the pieces are manufactured. In a circular approach, the stock of the members are already manufactured. We already know the lengths, the sections, the material properties of the components to reuse, and the new goal is to find the best shape, the best overall picture of the project that is a good fit for the project first, but also that reuses the components from the stock in the best way possible. And so to accompany that change, we are developing tools, design tools, that allow the optimization of the topology and geometry of steel truss structures, for instance, in such a way as to minimize the embodied carbon of the structure, or minimize the waste generated by the structure through the reuse of components. And we just recently we have published a plugin for the common modeling tool Rhino 3D. The plugin is called Phoenix 3D, and it does just that. So the user would provide a stock of members, steel members, and would set some constraints and objectives for the optimization and form finding process, and the result would be one of the possible structures that would reuse that stock of components in the best way possible.